So since last lecture we are working on transient analysis. As regards to transient analysis, the word transient has come from a transition where we either make an abrupt change in the present setup of the system, and usually the change is opening up of a switch or closing a switch. The transition may be single or multiple, but right now we are considering single transitions, and because of that transition the system has to respond to this sudden change, and how the system responds to this sudden change is being studied. Then we are considering the circuit. As regards to resistor based circuit, the transient analysis is not made because straight away whatever change in the setup we make, it is reflected in the circuit condition immediately, and that is continued forever for a resistive circuit. Whereas if either an inductor or a capacitor or both are there in the system, then the sudden change which we have made, that produces some kind of time based change in the system, and then system reaches to what we call as a steady state. Actually it doesn't reach, but after some significant interval we can say it to be as good as steady state. So we will go through everything. For that purpose, what we find is, since capacitor and inductor are reactive elements, since those are linear as regards to current and voltage, not in direct form but with differential form of either and another indirect form, whatever equation we get for solving is a differential equation. Then it would have been very nice if we would have been very strong mathematicians, which we are not, to solve the differential equation directly from the problem to solution without any hint. But since that capability we do not have, we try to take help of some hint, and the hint is, wherever we are having either a capacitor or an inductor in the circuit, wherever we are having either a capacitor or an inductor in the circuit, such a circuit can be solved by using what we say to be a solution of the kind a plus b e raised to lambda t. Everywhere voltage of any point with respect to another point or current through any branch is always of the form a plus b e raised to lambda t, and by solving, then what we can do, we can find its derivative. There is no problem. We can generate the equations by which we come to know about a, b and lambda, for which we are also required to know, since the reactive elements are there, there is something called as an initial condition at the time of transition. We presume transition takes place at t equal to 0. That also can be changed. There can be multiple sequence transitions. To everything we shall come slowly. And with knowing initial condition, we are able to find out a, b as well as lambda. That completes the solution. We have considered one problem. We will consider some more because it requires a detailed analysis. We consider different types of problems. So each type would be some kind of exercise for you. Now let us consider this. And we consider values such that we are not required to work on calculator. So it's 1 volt, 1 ohm and 1 henry, and the switch is closed at t equal to 0. Switch is closed at t equal to 0. Find out, this we can say VO, or we can also say VLT, means voltage across inductor, VRT and IT. You have to find IT, then VLT and VRT. All the parameters you have to find. So how can we begin? Once you get one, you can find others very easily. So let us presume that VOT, that is VLT, because it is at the output, right? At the output. So VLT we can consider. Let us presume that VLT is equal to A plus B e raised to lambda t. And we get this IT then state of VOT minus VLT upon R, and R is 1. IT we can write IT is equal to VOT, sorry, V in T, that is now 1 minus A minus B e raised to lambda t. This is the condition which is imposed on IT by the resistor. Similarly, the inductor will also impose some condition. What condition will impose? What condition will impose? Now there is a problem. We can solve, but this approach is wrong approach. Wrong means not a inconvenient. I will not say wrong. Inconvenient approach. We have made up our mind. May that be wrong. That derivative is simple. Integration is somewhat difficult. NPN transition is simple. PNP transition is somewhat difficult. So you cannot find IT from VOT because you have to go for integration. But if we assume IT, then you can find VLT. Why? Because it's by derivative. Is it clear? So our assumption was wrong. Or what we can say now, in the inductive circuits we assume current, and in capacitive circuits we assume voltage. We can solve by other means. So actually there is no, then one may say no, it is wrong approach. Basically our fundamental approach is not perfect. We are going by brute force method. You should not have any need of such thing. You should be able to solve differential equation classically. So that we are avoiding right now. So what we presume? We presume IT. We presume, are you getting me now? We presume IT would be like this. IT would be A plus B e raised to lambda t. Being series circuit, IT is common everywhere. Now we will put conditions. The resistor will require IT in some form. The inductor will require. Now we compute VOT, VLT based on this IT as directed by the inductor, as directed by the capacitor, by the resistor. Now what would be VLT? Since IT is this, VLT must be L di by dt. What is L? 1. So it would be, what it would be? Di by dt. So I is this. So 0 lambda B e raised to lambda. VLT is lambda B e raised to lambda t. Any query? VLT is lambda B e raised to lambda t. VLT can also be found by another equation. What is that? What we know? This we can say V in T. That is after we are counting after closing. So what is V in T? 1. So we know V in T minus VLT upon R, that is 1, must be equal to I. So what is VLT? V in T minus IT. VLT you can put on this side, IT will come on this side. So can I write VLT is equal to V in T minus IT, because R is 1, right? What is V in T now? 1. What is IT? Minus A minus B e raised to lambda t. And these two must be, these two are same. When these two can be same? When these two can be same? There is no constant term here. There is a constant term 1 minus a here. So a is 1. So immediately it gives rise to me that a is equal to 1 because 1 minus a must be 0. A is equal to 1. Right? And everything is brute force. So the moment at which I get a equal to 1, I put it here directly. Right? Now what must be equal? Lambda b must be equal to minus b. Lambda b is equal to minus b. When that is possible? That is possible. We don't have a single solution. That is possible when either lambda is equal to minus 1 or b equal to 0. If b is equal to 0, this we get as, this comes on the other side. So 1 plus lambda b is equal to 0. If either of this is 0, it is satisfied. So either b equal to 0 or lambda equal to 1. Now how we can find this? It's very easy to find. Now before the circuit is closed, that time initially the current was 0 because it is open circuit, current can't flow. So that condition must be given. Initially the current through the inductor was 0. When initially the current through the inductor was 0, what we can find? I0. I0 is equal to what? 1 plus b, correct? I0 is 1 plus b. Is it okay? Because this at t equal to 0, it is 1. And what is that? That must be equal to 0. So what is b? B is minus 1. Or you can find it here itself actually. Actually, there is no need to. Now we have understood the problem solution. In brute force method, we develop ourselves to decide what to be done first. So what do we do? So now we should have done that first. So immediately we might have got rid of b itself. So now b is minus 1. As b is minus 1 means b is not 0. So lambda must be minus 1. So a equal to 1, b equal to minus 1 and lambda equal to minus 2. This is the solution. That is 1 minus e raised to minus 1. Is the current. Current is 1 minus e raised to minus 2. That is of this form. VLT, what is VLT? Its derivative. That is, what is that? E raised to minus t. VLT is e raised to minus t. Now sometimes there are two approaches. The thing should be elaborated in a simple manner, so that is one way of looking at it. But that technique may make the students handicapped. Therefore, sometimes a jerk needs to be given, so that the student should get immediately stunned, and in that state it is what we can say an elevated state where learning of few things may be more easy. It is just like, suppose if we are having a iron rod and it is shaped, then in its cold state you can shape it slowly. In its cold state you can shape it slowly, but it takes much time to shape. Rather, it is also possible the shaping is appropriately done if the metal rod is heated up, and in the heated state it can be shaped by punch. So with this we try to just with the same background. So solution is a plus b e raised to lambda t, and based on that we try to solve something in which we solve as if we don't know any other thing, and let us see what happens. In this we have to work on integration, a small piece of work that I think we can do. Initially the current to inductor was 0, voltage across capacitor was 0, because state of the capacitor is described by voltage, state of the inductor is described by current. So IT and VCT both were zeros at t equal to 0. IT and VCT both were zeros at t equal to 0. So IT we can presume as again a plus b e raised to lambda t. At t equal to 0, what is I0? I0 is a plus b, that is equal to 0. What is V0t? V0t is also 0. V0t is also 0. So a plus b equal to 0, we have got one equation. A plus b equal to 0, we have got one equation. Then VCT is also 0. VCT is also 0. So when VCT is also 0, VCT at t equal to 0 is also 0. So when it is so, what good idea can we make? What is VCT actually? Integral. What is VCT? VCT is integral 0 to t I tau d tau. Is written in this form. So what it comes out to be? This is written because the other will be replaced, because we have to have this variable here. So that is equal to a plus b e raised to lambda tau d tau. What is this integration? It is a tau plus what it is here? B upon and plus C, but that goes because it's a definite from 0 to t. This is from 0 to t. So what this is? What this comes out to be? At t equal to 0, what happens? At tau equal to 0. At tau equal to 0, this goes at tau equal to t. It is at plus b upon lambda e raised to lambda t, right? Minus at tau equal to what it is? At tau equal to 0, this is 0. This is 0 means minus
b upon lambda.
So that is VCT is equal to VCT is equal to what? Whether it's correct or something wrong there?
Correct.
It's correct, right? So it is equal to minus b upon lambda plus at plus b upon lambda
e raised
e
to
raised to lambda t. It is VCT. And at t equal to 0, what it is? It must be 0. So at t equal to what it is? At t equal to 0 is minus b upon lambda. So what happens? Do you get an answer? Do you get an answer here? Something wrong here? A plus b raised to lambda t. A t plus b upon lambda. So what do you got? At t equal to 0, this goes, so it becomes 0 only. It will be like that. A plus b is to lambda t, its integration a tau plus b raised to lambda tau. So at plus anyway, I think this is the expression at we will solve further. So now we have got a plus b equals to one relationship. We have got relationship of VCT. We have got relationship for VCT. Now if we know VET. We have found out VCT. We know VET. We have found out VCT. We have assumed IT. We have assumed IT. VCT, if it is its derivative, are we correct? Yes, it is A and plus B. So no problem. It's correct proposition. Now further what we can do? Further, IT we have assumed. VCT we have calculated based on capacitor's property. Now we can find out VC based on inductor property. How? What is inductor voltage? L di by dt. L is 1. So that must be equal to what? This minus this. L di by dt should be equal to V. So VLT is equal to VNT minus VCT. Is it correct? Right? What is VNT? 1 minus this means plus B upon lambda minus AT minus B upon lambda e raised to lambda t. Correct? What is this? This is VLT. But we have presumed IT. We have presumed IT. So what is VLT as governed by inductor? L di by dt. What is L1? So di by dt. What is that? This must be equal to
B lambda e raised to lambda t.
lambda b e raised to
Lambda t.
lambda. Is it correct? So the understanding index is not proportional to the way in which it is set. So now when we match the terms, what we must have? In terms matching, what we must get? What idea we can get about A and B? Any idea do you get? Are we able to proceed further in this brute force method? What terms must be equal?
VLT पण 0 पाहिजे ना t is equal to 0. मग त्याचे एक इक्वेशन येतेच की झाले 3 आणि 3 इक्वेशन लॅम्बडा b e raised to lambda t किती मागतो L into di by dt VLT म्हणजे लॅम्बडा b into e raised to lambda t is equal to 0. 0 is equal to lambda into b lambda b 0 म्हणजे either lambda is equal to 0
Are we able to progress or we have stuck up with some fundamental error? How will you solve? And what about A and B? And B?
L into di by dt म्हणजे हे झालं L into di1 म्हणजे VLT झालं.
Oh, what? Here there is one problem. Somewhere we might have gone wrong in the calculations. We can come to that. So here, what if we right now ignore these things? This right now we don't consider right now. So if we only look at these two things, what we get? Lambda b is equal to minus b upon lambda. So we get something like lambda square equal to minus 1. We get something like lambda square is equal to minus 1. So this leads to an imaginary lambda. So e raised to minus zt results in e raised to minus zt results actually it gives rise to either plus j lambda square equal to minus 1. What is lambda? Root of minus 1, or it actually lambda is plus minus root of minus 1. Lambda is plus 0 minus 2. Actually it results into a combination of two. Something into plus j and something into e raised to plus j something and e raised to minus j something. So plus j is giving e raised to zt is cos t plus j sin t, and e raised to minus zt is cos t minus j sin t. If we add them or subtract them, in that case we lead to a sin term or a cos term. So whenever we get a circuit like this, it leads to oscillations. This circuit leads to oscillations. The errors which we are getting right now in the assumption are because of our a plus b e raised to lambda t. Then in that case, if we make it more appropriate, in that case we can have one again a brute force presumption. We can have one brute force presumption. That presumption would be, it is of the form a plus b e raised to lambda t plus c e raised to minus lambda t. It is a plus b e raised to lambda t plus c e raised to minus lambda t. Actually, in again taking that lambda, you can take lambda is equal to actually sigma plus j omega. Lambda is considered this, which is now complex number, sigma plus j omega. So we can have it a plus b e raised to lambda 1 t plus c e raised to lambda 2 t, where lambda 1 is sigma plus j omega and lambda 2 is sigma minus j omega. And by this, are you getting me? So it would be a challenging problem because it is not yielding into simple solution. The brute force, actually it is evolution, not here in brute force method, but everywhere. What happens that when a postulate is met, so it is of the form a plus b lambda 1 t plus c lambda 2 t. It is of this form. To be more precise, actually it comes out to be so actually it leads, if we go it's some classical analysis, then it leads to a second order differential equation. It leads to a second order differential equation for which we have to think something regarding the brute force method. So at this juncture, let us conclude that this is some problem which we have encountered. We are in learning phase. So a circuit consisting of inductor as well as capacitor, we end up with some problem. How to solve that we shall come immediately afterwards. Then we may take one more.
Android काढून टाका आणि पुन्हा इन्स्टॉल कर. स्लो झाले ना.
Now find out VOT. VOT is voltage across resistance. Find out, the problem is find out VOT. Find out VOT. find out VOT. And obviously when the switch is closed at T equal to 0. And initially this voltage was 0, this voltage was 0. Initial voltage across both capacitors was 0. Initial voltage across both capacitors was 0. Now we first try the differential equation and then try to see whether can we solve something by brute force. So we came to know about the limitations of brute force method. That was when there is either one inductor or one capacitor, it worked fine. When there was one inductor and one capacitor, it worked fine. Now here there are two capacitors. Let us write the differential equation and try to see in what way we can solve this. In what way we can solve this. Actually, lambda 1 and lambda 2 will be solving the purpose. A plus b e raised to lambda 1t plus c e raised to lambda 2t may solve this in this case. In this case, it is possible that voltage at every r, voltage at every point can be of this form: a plus b e raised to lambda 1t plus c e raised to lambda 2t. By this way we can solve something. That's what we feel prima facie. But whether that would be a correct approach or not, and once, since in the brute force method we have presumed something, we have to cross verify everything to convince ourselves that the brute force method is the correct method. We are going by this different approach because learnability of the students is important. So whenever either inductor or capacitor comes, to find the answers for voltage and current anywhere in the system, we need to solve differential equation. Differential equation we are not that much comfortable. Therefore we are trying, rather than finding the solution, we are assuming the solution. From the solution we are trying to rewrite the equations again, presuming that knowing the type of the solution, the differential equations become linear equations. By coefficient matching we are trying to achieve something. So for this, or to make just a small change, we make this 2. So it will provide us. So then, can you write the differential equation easily? It is not so easy to write. It is not so easy to write. Therefore, we presume that this voltage is equal to A plus B e raised to lambda 1t plus c e raised to lambda 2. A plus B e raised to lambda 1t plus c e raised to lambda 2t. Let us assume that this is the voltage. After that, how can we proceed further? One thing which we can do immediately is at t equal to 0, what it is? At t equal to 0, it must be 0. So what must be 0? At t equal to 0, we must get A plus B plus C is equal to 0. We get one equation. And that we can very immediately put here. So A is equal to minus B minus C. A is minus B minus C. So voltage is minus B minus C plus B e raised to lambda 1t plus C e raised to lambda 2. Is what? Is the VOT. Is it right? Is it alright? So we have just reduced the variables. Now, what would be IT? What would be IT? I mean, or this I can say I2T. This I can say I1T. This is I1t. This is not same now. This is I1t. This is I2. The same will be here, but it will be different. Now we may not be able to find the exact solution because it is somewhat tedious process, but we will give the hint. So what is IT now, or I2t? This voltage is this. So what is C dU by dt now? Now C is 2. So I2t would be equal to 2 into this goes right plus what? 2 into lambda 1b e raised to lambda 1t plus lambda 2c e raised to lambda 2t is what? I2t is what? I2t. Is it correct? Then this point you can give, say point B you can give, no problem. This point will be as D because BC there will be some confusion. So what would be VBT now? What would be VBT? So you know I2t. So VBT minus VOT must be equal to this because it's a resistor. VBT minus VOT must be equal to this. We know VOT. So VBT is VOT plus I2t because this R is 1. So what is VBT now? VBT is equal to VOT, that is minus B minus C plus B e raised to lambda 1t plus C e raised to lambda 2t plus what? Plus I2t, that is 2 lambda 1 B e raised to lambda 1t. So we write it comes one below other plus 2 lambda 1 B e raised to lambda 1t plus 2 lambda 2c e raised to lambda 2t is what? VBT. Is it correct? Is VBT. Any query here? No. VBT. Now, knowing VBT, what can you find? Knowing VBT, now what can you proceed further? We can find
I1t.
Can you find I1t directly?
Current
Yes.
capacity.
But it is?
Sir, it current to capacitor. I1t is full current. I2t plus current to capacitor.
So we have written
VBT
VOT.
minus VOT upon
We
R
have
is equal to
written,
I2t.
actually we have assumed VOT just by putting a content equal to we have done something. We have found VOT we have, I2t we have, VBT we have, then I1t can be found. What is I1t?
I2t plus
I1t is equal to 1 minus VBT. I1t is 1 minus VBT. So I1t is equal to 1 minus VBT. It may be of use, it may not be of use directly right now. Right. Now, what is this? Here we get the final punch. I3t. What is I3t?
I1t minus I2t.
I3t is
VBT upon I1t minus I2t
is dVBT by dt because C is 1. So I3t is what? Its derivative. I3t is its derivative as well as it is I1t minus I2t. And then you should match. Then what? After that, so you should be able to get values of B, C, lambda 1 and lambda 2. B, C, lambda 1 and lambda 2. So anybody found something?
टाकता येतं 1 minus dbt plus
I1
b
कसं काढायचं
plus
असतं?
c plus b
I1
plus
कसं
c
काढायचं?
minus d
What is the answer?
plus 2
I1 कसं काढला?
अजून काढला नाही याच्यावर काढते I1t is minus I2t is equal to I2t कडे टाक I1t निघतंय
I2 ठीक आहे.
I2t ची व्हॅल्यू दिली आहे की इथं
I1 minus I2 I1 काढायचं
हां
कसं?
I1t minus I2t is equal to काय असते आपलं I3t आणि दॅट इज इक्वल टू dVbt बरोबर आहे dVbt ची व्हॅल्यू ही झाली I2t ची व्हॅल्यू इकडे टाक म्हणजे I1t म्हणजे dVbt प्लस I2t
आपल्याला दोन्हीचं कंबाईनच करायचं आहे ना आपल्याला एक क्वेश्चन
I3 आहे I3t आहे
I3Tचं हे आलेलं इक्वेशन ते सोडलं आणि I1t मायनस I2t हे कंबाईन करायचं आहे ना
मग मी तेच केलं इथे
तू याच्यावरच जे काढायला लागला तर कसं करायचं
अरे इथं ते सेम केलं आणि हेच सोल्युशन इकडे घेतलं आणि डायरेक्ट 2 स्टेप कमी केलं म्हणजे माझ्याकडून
Got the answer? What is the answer? All answers you got? So I1t minus I2t you can find, that is 1 minus VBT minus I2t, and you can find derivative of VBT. What is the problem now? Anybody have found out B, C, lambda 1, lambda 2? Lambda 1? Lambda 1 is minus 1. Lambda 2 minus half. Is it? No, we should not have. See, obviously, transient analysis is not simple thing. We are trying our level best to make it simple. I hope that the Laplace transform is about to be over in maths M3. So the differential equation is over. First Laplace transform. Differential equation you learned last year. For basic differential equation solution you must have learned. So now either we may go by solving classical differential equations or we may go by solving Laplace transform. We may go by solving Laplace transform. And by that things become substantially simple. As regards to this brute force method, actually the idea is one reactive element brings one lambda 1 or one reactive element brings one lambda, that is we get e raised to lambda 1t plus e raised to lambda 2t. So when we have one capacitor, 1 lambda, one inductor, 1 lambda. So if we have got LC pair, then 2 lambdas what we get are complex conjugates. In an LC pair, the lambdas which are there are complex conjugate. In other cases, these are not. So one reactive element brings 1 lambda. So the solution is if for one capacitor or for one inductor, and obviously if when there is no element, straight away we get only constants. So when one reactive element is there, solution is of the form A plus B lambda t. When two elements, A plus B lambda 1t plus C lambda 2t, like this. So what I would like to appeal to you, that you try to think over this on your own, try to construct some problems of switching and try to find the solutions. It is not difficult, only thing is that you should work with patience. You need to write down neatly, because if in some step it goes wrong, everything will go wrong. So after stepwise writing, you will be able to match. What you will be able to match now? 1 minus VBT minus this is equal to, what is this? D by dt of this? D by dt of this will come as, d by dt of this will become 0. So it will come, lambda 1 will come here, lambda 2 will come here, lambda 1 square will come here, and lambda 2 square will come here. So this would be I3. This would be I3. This would be I3. Okay? Then when the square term comes, what we may get? We may get two solutions for lambda 1 and lambda 2. We get a quadratic equation for lambda. So with this we can solve. So I hope that what we are discussing, for circuits consisting of reactive elements, we are trying to find out a brute force method which is simple, in which we assume the solution, and based on that assumption we proceed and try to find out the constant, so that we get the complete solution. And we will come to a conclusion after some time that sometimes we find that the brute force method, even though it is simple, it takes on so long path and so many assumptions for different cases. It is maybe better to learn the classical method, or Laplace can be said to be having the advantages of classical method of a unique type of solution for all the problems, and it also has the advantage of brute force method is simplicity. So you will find it by Laplace transform, you can find it better. Means classical way differential equation, brute force way knowing that the answers of this type, using the type of the solution as a hint and trying to solve, and then Laplace transform. So our